So this is going to be 3, 5, 4, 5. So we're going to be talking about parallel lines, triangles, equilateral triangles, equal angular triangles, isosceles triangles, and stuff like that. So parallel postulate, if I have any point, there will be a line that is parallel to it. Okay, this is the basis of Euclid geometry. Okay, the sum of the measures of a triangle is 180 degrees. So that means if I added all my angles in a triangle together, it should be 180 degrees. Okay, to find the measure of angle 1, I have two angles. The total should be 180. So if I add these two to get 142, I can subtract that from 180 to figure out what that angle is that's left. So the measure of angle 1 is 38 degrees. Okay, this one, I'm going to look at the triangle that has the most information. So this triangle here, I have two of them, the 43 and the 59. I can find my last one. So if I add 43 plus 59 to get 102 and subtract that from 180, I get 78. So the measure of angle X is 78 degrees. That's an 8. Okay, and this makes a straight line. So I can start jumping from one triangle to the other. To find it, since it makes a straight line, I can do my 180 minus 78 to get 102. So the measure of angle Y is 102 degrees. Okay, so now if I'm looking at this other triangle here, I have the two angles, I'm missing my third one. So if I add 102 plus 49, I get 151, and subtract that from 180, I get 29. So the measure of angle Z is then 29 degrees. So you can jump from one triangle to the other. Okay, definition of exterior angle of a triangle and remote interior angles. So the exterior angle is the angle that sits on the outside. The remote interior angles are the blue ones, the ones that sit on the inside and are not attached to the exterior. So the ones that are not attached to that exterior angle. Okay, triangle exterior angle theorem. If I add my two remote interior angles together, it will equal that exterior angle. So if you add the two angles not attached to it together, it should equal that exterior. Okay, so if I add my two interiors together, I get 98, which means angle 1 should be 98 degrees. Okay, I'm going to zoom in on this one. This, I could do two different ways. I could say angle 2 plus 59 should equal my exterior, 124, in which case I would subtract. So my angle 2 would be 65 degrees. Or what I could do is take 180 minus 124 to get 56. Add these two together and subtract it from 180, and you should still get the same answer. Okay, defining a triangle. A triangle is a figure with three line segments joined with three non-collinear points called triangle ABC. Okay, so if I'm coming from angle A is one of my vertexes, because a vertex was always the center of an angle. And since we have three different angles represented in this, 1, 2, 3, all three of those points are considered vertexes. Okay, so if we're coming from A, the side opposite or across from it is going to be called the opposite side. So side BC is the opposite side to angle A. Adjacent, we learned, is something that sits next to something. So the sides that are adjacent to angle A are going to be AC and BA, or AB. The sides that sit and are connected to it, they're adjacent. Okay, defining the triangle. What's the name of this triangle? Well, we could say triangle and then include the letters. So let's say DEF. We could also say triangle FED. We could say triangle EFD. It can be any order of the letters as long as you put triangle in front of it. So what are the sides adjacent to angle E? So adjacent, we said, sits next to. So one side could be DE or ED, this side. The other adjacent side is FE or EF. And then the side that sits opposite or across from it is DF or FD. Okay, we can classify triangles by their sides. We have an equilateral triangle, so all these sides are equal. We have an isosceles triangle where two sides are equal, and those two sides are called the legs, and it also has a base. Okay, and then we have a scalene where no sides are the same. So try to remember isosceles has two sides the same, equilateral, three sides are the same. If we wanted to classify it by its angles, acute, all of the angles should be smaller than 90. Obtuse, we have one angle being bigger than 90. Equal angular, it says equal in it and angle in it. So all of our angles should be the same. A right triangle should have a right angle in it with its two legs and a hypotenuse. Isosceles and equilateral triangle. So here's an isosceles triangle with our two legs right here being congruent, our base and also our base angles. So B is always going to be the vertex angle, and it's always going to be the angle that's connected with the two congruent sides. Oops. Say it is connected with the two congruent sides. Okay, so if I have an isosceles triangle and my two sides are congruent, here's something you're going to have to know for the rest of the semester. If those two sides are congruent, then the two angles across from the vertex are also congruent. So if I have two sides being congruent, the two angles are also congruent. The converse of that, if I have the two angles being congruent, that also means that the two sides should also be congruent, so the opposite direction. So whenever you have two sides being congruent, there will always be two angles that are congruent. If you have two angles being congruent, there will always be two sides that are also congruent. Okay? If a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. So basically, it creates this perpendicular line. And if it's an angle bisector, it creates these two tiny congruent angles right here. Okay? And you can make lots of them in a triangle, as you can see down here. Okay, corollary to 4.3, if I have an equilateral triangle, so all the sides being equal, it is also equal angular, so all the sides are also equal angular. So if I have it equilateral, all the sides being congruent, that also means all the angles are congruent. And vice versa. If all of the angles are congruent, that also means all the sides are congruent. Well, if all three angles are the same, and all angles should add to be 180, that means all angles in equilateral or equal angular triangle are 60 degrees. This is big. So if you have an equilateral or equal angular triangle, the angle should be 60 degrees. Okay, solve for x and y. So I have this representing 90. All angles in a triangle should add to be 180, so let's go ahead and add 65 plus 90 to get 155, and subtract it from 180 to figure out what our x is. Which is 25, so this represents 25. Okay, if I have a right triangle, to find my missing side, I could use the Pythagorean theorem. Okay, C always sits across from my right angle, so I'm going to label this A, this B, and this C. So it's A squared plus B squared equals C squared. So I got 3 squared plus 4 squared equals C squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. Opposite of squaring is square rooting, so we're going to square root both sides. The square root of 25 is 5. So this y side here represents the length of 5. Okay, this one, if all of the angles are equal, that means it's equilateral and equal angular. So if all of my angles are equal and it's equal angular, that means it should be 60 degrees. All my angles should be. So if I set this equal to 60 and divide by 5, my y is going to represent 12. Well, if it's equal angular, that also means that it's equilateral, which means all of my sides should be congruent or the same. So if they're congruent, that means we can set these equations equal to each other. So I'm going to subtract 3x and add 6 and divide by 2. So my x is equal to 4, but I want to find the missing link, so I'm going to go ahead and plug this 4 in. 3 times 4 is 12. 12 plus 2 is 14. If all the sides are congruent, that means this also represents 14. Solve for x, y, and z. Well, these 9s show me that all of these sides are the same, so they're all equilateral. So that means it's also equiangular, which means all of my angles should be 60 degrees. So I'm going to set them all equal to 60. So divide by 4 in this one. So y is equal to 15. Divide by 5. So z is equal to 12. Divide by 3. So x is equal to 20. Okay, these lines mean it's equilateral, which also means it's equiangular, so that all my angles then should equal 60 degrees. So that equals 60. This makes a straight line, so if I want to find out y, I can take 180 minus 60 and get 120, so y represents 120 degrees. Okay, this, I'm only seeing 2 sides in any of these congruent. So if I have 2 sides congruent, we know they're isosceles. Isosceles triangle, if I have 2 sides congruent, that also means the 2 angles across from the vertex are also congruent. If they're congruent, it means they should be the same, which means we can set them equal to each other. So I'm going to take my 3x plus 10 equal to my 5x minus 10, subtract 3x. I'm going to add 10 in the same step, so I'm going to get 20 equals 2x. Divide by 2, I got x is equal to 10. Okay, but I'm still trying to get to y. So this, let's go ahead and find this angle. So I got 3 times 10 plus 10. 3 times 10 is 30. 30 plus 10 is 40. So you know that's 40. If they're congruent, that means this also represents 40. To find this angle, I have both of those being 40. So 40 plus 40 is then 80. To find that other angle, all triangles should have 180 degrees in them, so 180 minus 80, that is 100. Okay, this then makes a straight line, so if I take 180 minus the 100, I could get this angle here, which is then 80. And if these two are congruent, that also means these 2 angles, I'm going to choose a different color here, that also means these 2 angles are congruent. So that means I can set them equal to each other. So the other one is 80, the other one is 4y, so we're going to set them equal. So my y then equals 20.